Here we're going to look at question 90 from the NSAA 2018 paper. In this question, we're told we have an object which is thrown vertically upwards at a speed of 40 meters per second. We're then told that 2 seconds later another object is dropped from a height. Both objects then hit the ground at the same time, and the question asks us at what height is the second projectile dropped from. Now if you'd like to have a go at this question, please pause now, otherwise let's have a go at it. So as we can tell, this question is going to be about projectiles. Now there's one thing which we pretty much always use whenever we're looking at projectiles, and that is the SUVAT equations. So how about we see if they're going to fit in here. So let's consider our first projectile, which moves upwards at 40 meters per second, and let's try and figure out what each of the variables could mean for this equation. Well, we're looking at the point when it hits the ground again, so when the displacement is 0. We also know that the initial velocity is going to be 40 meters per second. We don't know what the final velocity is going to be. We know the acceleration is going to be the acceleration due to gravity, g, in the downwards direction. And we don't know the time which is going to take. Now, how about we look at our second projectile, which is going to be dropped 2 seconds later. So here we're going to be looking for the displacement from its initial of minus h. The initial velocity is u since it's dropped from rest. We don't know its final velocity. The acceleration is going to be exactly the same, and the time is going to be the same thing, but 2 seconds less, because it's dropped 2 seconds later. So if we're going to use our SUVAT equations, then we need 4 variables, or we need to look at 4 variables. So we're going to have to look at one of the ones which we don't have. Now this could either be the final velocity v, or our time t. What I'm going to do is pick our time t. Now the reason for this really is that the velocity equation would have to be v squared equals u squared plus 2as. And if you try solving this, then you'll see that actually, if you do the equations one at a time for each of the projectiles, then we'll get an imaginary value for this for our second projectile. So obviously our equations here don't quite work in this scenario, but if we use time, then as you'll see, this is going to work. So if we do want to try and find the time, which equation should we use from our SUVAT equations? Well, we're going to want to use this equation here because it contains all of our variables which we've got. So if we substitute in our values and t, which I've put as a t here, then we get this equation, which we can factorise, bring the t out to get this. So t is going to be either equal to 0 to make this right-hand side of the equation 0, but this is just going to be the point at which the projectile is fired. So it's not that value of t which we're looking for, it's the other one, which we find by solving this bracket equal to 0. So t is going to be equal to 40 divided by 5, which is 8 seconds. So we know that this projectile is going to hit the ground after 8 seconds in the air. Now we can go on to consider our second projectile. So here we're going to use the different SUVAT variables, and now our time is going to be equal to our 8 seconds, but take away the 2 seconds because this projectile is fired 2 seconds later. So the amount of time this projectile is going to be in the air is just 6 seconds. Now substituting all of these into the equation which we've got at the top here, then we get this equation, which we can simplify by using g equals 10 to get that h, the height, is equal to 5 times 36, which is just going to be equal to 180 meters. Now this height is going to correspond with answer B given in the question.